Hello everyone, today we are going to solve the next question from the book SS Krotov. The question is 1.4 from the mechanics part, and the question says a point mass starts moving in a straight line with a constant acceleration a. At a time t1, after the beginning of the motion, the acceleration changes sign, remaining the same in magnitude. Let's formulate the question. This is, we have a point mass and it is moving in this direction with acceleration a, and it starts moving. It means its initial velocity is 0. So it starts moving in this direction, and after time t1, this is time t1, total time t1, its sign changes. So acceleration becomes this in this way. So it again moves. Let's say this time is t2, and here its velocity will become 0. So its velocity is 0 at this point of time. So we can solve something by simple calculation, that a body moves from 0 initial velocity having acceleration a, moves for time t1, and then when its velocity is say maximum, its direction of acceleration changes. So now its velocity becomes 0 again, final velocity, and in time t2. So by symmetry we can say t1 is equals to t2. Otherwise we can solve it. So how can we solve it? Let's say here we have a velocity v1. v1 is equals to u plus a t1. U is 0, so a t1, final velocity is a t1. So here we have the velocity a t1. Now here we can say v is equals to u plus a t2. Suppose this time is t2. Final velocity is 0. Initial velocity is this velocity. Okay, so initial velocity is a t1 minus, because acceleration is opposite to the direction of velocity, so it will be a t2. So we can say t1 is equals to t2 from this position. So now let's solve what is the distance traveled by this point mass in this time t1. So s is equals to ut plus half at square will be the distance traveled. So let's say s1, initial velocity 0 plus half a. What is t? T is t1 square. And what is the distance traveled during this time interval? s2 is equals to initial velocity is a t1, that is u. S is equals to ut. T is t2, this is u. S is equals to ut minus half a t2 square, minus because acceleration is opposite to the direction of velocity. So this is the total displacement. Now body is moving from this point to all the way this point. Now this time is say t. Now we can use the simple equation, s is equals to ut plus half at square. Now here we have velocity v is equals to 0. So initial velocity in this case is 0. This is 0 plus half a t square. Half a t square. This is the equation we are going to use. And what is this distance s? That is equals to s1 plus s2. And we can put the values of s1 and s2 from this equation. Now if we will solve this, we will get half a t1 square plus this a t1 t2 minus half a t2 square, that is equals to half a t square. Now we can cancel a, dividing the whole equation with a on both sides and multiplying the whole equation by 2 on both sides. We will get t1 square plus 2 t1 t2 minus 2 t2, sorry, not 2 t2 square is equals to t square. But t1 is equals to t2. So if t1 is equals to t2, this will get cancelled. We don't have t here, so this will be 2 t1 square is equals to t square. This will be t is equals to under root 2t. So this is time, so we are not going to consider the negative value. So this is t is equals to 2t1 t2. Now they are asking about determine the time t from the beginning of the motion in which the point mass returns to the initial position. I have considered this t, say let's say this is t dash, so we don't get confused. This is say t dash and this is t dash. I want total t, and t is total time, this time and then this time, this total time is t. So t is 2t1 plus t dash. Why I am writing 2t1? Because this t1 plus t2 is t1 and t2 are equal, so I can write 2t1 plus t dash. So this 2t1 plus t dash is equal to under root 2t1. Now taking this t1 common, this is under root 2 plus 2. This is my answer. Thank you.